Okay, Bismillahirrahmanirrahim. Analysis of algorithm, recursive functions, that is factorial of a number. So how could we find it? So first of all, we need to know about factorial of a number. For example, 5 factorial. It can be represented by this, like 5 factorial, and it must be equal to 1 multiplied by 2 multiplied by 3 multiplied by 4 and multiplied by 5. Okay, so when you reach to the last, the given number, that is 5, so it's equal to 120. So it means that 5 factorial is equal to 120. So how we can program it? We can program it by many ways, many methods, but the most important is this one. This is actually a question being sent by my student. Compare the below algorithms and explain the number of steps according to the algorithm analysis. So analysis of algorithm, you know that it's a subject and where we analyze some algorithms, and by analyze or by analysis of an algorithm means that we find time complexity, okay, and we find space complexity. Okay, we find both of them. Okay, and we call it analysis of algorithm. Time complexity means how much or how longer an algorithm takes to execute, and how much space it takes in terms of hardware. So we can say that both are very important, and the subject by itself is very important for any software developer. Well guys, the question is asking about the steps, so it's quite easy question. Whenever you're going to find out the steps of any algorithm, so you need to know some basic, and those basics are, first of all, the name of a function by itself. No need to consider it as a step. Okay, and then the opening brace, so also no need to consider it as a step. Well, the body actually, the definition itself can be considered, some steps of an algorithm. So for I equal to 1 to n, so it's actually your step number 1, and then this is the inner side. It's the part of the for loop. Okay, so it can be considered as, we can say it's a inner step, so it can be considered as step 2, and obviously it will return a result, the factorial, and it's called step 3. So it means that in this program we have total steps 3. It's solved. Next question, the B part of the same question is, this program is also for factorial, finding factorial of any given number. So in this program, you can see, in this algorithm actually, you can see here, we may have the same rule we can apply. Just count the statements inside the function definition. Fn equal to 1, it's a step 1, return 1, step 2, and don't count this one as a step. You have to count what actually the else body done, that is return n multiplied by factorial of n minus 1. So this is called, we can say, the steps, and the same algorithm also has 3 steps. Okay, so it means that both has 3 steps. Okay, let's go ahead and find the time complexity of the a number. So well, it was having for loop. Okay, so keep in mind, whenever you're going to find the time complexity of any algorithm, so you have to find the cost of that step, being step 1, 2, 3, depends upon the number of steps, while the second is frequency. It means how many times this statement is executing inside your computer RAM. Well, so it is always executing n plus 1 time, mean the outer loop always executing n plus 1 time. Why? Because, for example, we have 10 values in a computer RAM, or inside computer we have 10 values, so it means that your for loop will execute 10 times. But why plus 1? Plus 1 always it's executing for, you can say, to become false, for false it's executing one time. So we can say the outer loop is executing n plus 1 times. Well, and the next step is the total cost. So you have to multiply the cost with the frequency, and similarly for step 2, its cost is C2, and keep in mind the body, that the part inside the for loop, that is fact is equal to fact multiplied by I. This is n. Keep in mind this is n, n plus 1, and this is n time, and the cost will become, the total cost will become C2 multiplied by n. And same is the case with return fact. Keep in mind we don't have any calculations over here, just we have the result on screen. So for this it's always executing one time, okay. And you can see here the multiplied by C3 multiplied by 1 becomes C3. So now we can find a time complexity. How? Time complexity can be denoted by T of n, and then you have to add all these, C1 into n plus 1 plus C2 into n plus C3, and when you multiply all these, so C1 means having n values, you can make it one side and the constants on another side, and then you can see here's n1 into C1 plus C2 and plus C1 plus C2. Keep in mind, in analysis of algorithm, you don't need to write the constant whenever you're going to calculate the time complexity. So here the T of n is directly proportional to n, and its order of n, big O n. It means that this is the time complexity of your algorithm number A, okay. So it will take this much time inside your computer. That's good. Let's move towards B part, and the B part is self-explanatory, very easy. This is another method to find out the time complexity. Okay, so let me explain it. The algorithm is having factorial of n. If n equal to 0, return 1. Means if the given n is equal to 0, it means that you don't want to find out any factorial of it. It may be from computer someone may enter 0, so the factorial of a 0 is always 1. There is no need to calculate something over here. Then it means that it must execute one time, okay. And then else return n multiply it means this multiplication must be executed one time, and n minus 1, and this must be executed one time. It means that these are the constant factors we need to consider it. Well, let's come towards this side and find out the time complexity of the algorithm B. Well, students, keep in mind T of n is equal to T of n minus 1. It's called recursive function. Plus 3 means you can find it 1, 2 and 3. That's good. If n is greater than 0, it means that if you enter from your computer 5, 3, 110, so this equation is for that. And T of 0 is equal to 1. It means that if you enter 0 from your computer for finding factorial of 0, so it also equal to 1. So it means that it's actually for n is equal to 0, this one. Well, now find out the time complexity. T of n is equal to T of n minus 1 plus 3. Actually it's recursive, okay. On this side, if you take T of n minus 1, okay, so on the place of n you need to put n minus 1, so minus 1 become 2, and plus this 3 will become double, it will become 6, and then you have to add 3 all the times, because we have to count these calculations 1, 2 and 3 times, okay. And next you have to add 3 with 6, so it becomes 9, and so on. So you are coming down, and we put, instead of 3 we put a k, means when it reaches up to some constant, maybe 4, 5, 10, 11, so let's put for that k, and let's put for the I mean for that multiplication we put k. Okay, that's good. Now n minus k, t of n minus k, so we consider that n minus k equal to 0, that is k equal to n. So t of n is equal to t of 0, because this factors become t of 0 and this becomes t of n. We put n instead of k and it becomes 3n plus 1. Well, in short, let me tell you, don't get confused. This is actually t of n is directly proportional to n, and it means that order of n. So it means that the time complexity of both the algorithms are the same. That is why we comparison cannot be made, because both has order of n time to execute this algorithm. So that's it from my side. Thank you so much.